Higher order derivatives. All right, so take a look at this first derivative section. We talked just before about f prime of x, y prime, we already know that. But these two new ones, dy dx, dh dt, and you're not limited to those either. So let's say you had an equation where here's a square and you want the area to relate to the side lengths s, and we get a is equal to s squared. Then you might have a slope where it's d capital A over ds. So it just kind of depends on what variables you have to get your first derivative. Now, here's the new stuff. Higher order, there's the second derivative and beyond. So, second derivative, take a look at this. F prime of x turns into f double prime of x. Y prime turns into y double prime. Now here's where it gets a little weird. You would think, okay, now if I have a dy dx, how do I deal with that, right? Well, it turns out it looks like this. You do d squared y over dx squared. Similarly, if you have a dh dt, you do d squared h over dt squared. What do you think dA ds turns into for its second derivative? It's going to be d squared a over ds squared. Okay? Alright, so, well, let's talk about what a second derivative really means. Okay, so let me just give you an example. Let's just say I have an equation y is equal to x to the fourth plus 3x to the second power. Okay, so a first derivative would look like this. 4x to the third plus 6x. A second derivative just means take the derivative of the first derivative. And you'd get 12x squared plus 6. That's all a second derivative is. Well, we can go more, right? A third derivative might look like 24x, and that's all. Okay? Well, let's talk about what if we have more than a second derivative. What if we have a higher order, like an nth derivative? Okay, this is how you would write the nth derivative. It's like, let's say you had like, I wanted to find the 10th derivative of y. You wouldn't write 10 hashes like that. Instead, you would write it like this. Okay, y parentheses n, and that tells you it's the derivative. Okay, so just like f prime of x would be f in the exponent spot, the parentheses n. Instead of d squared y, it would be d ny over d x to the n. Okay, and same thing with this h or t. Alright, so let's do an example. Here is y equals 2 cosine pi over 2x, and it's asking for that thing. What is that thing? It's basically asking, this is another way of saying I want the second derivative. So let's find our first derivative. We know that it's going to be 2, the constant, times the derivative of cosine. What is the derivative of cosine? That's the outside function. It's negative sine. What do we do to the inside? Keep the inside times the derivative of the inside, which is pi over 2. So if I clean that up a little bit, it's going to be just this 2 and that 2 cancel, and it will be negative pi sine of pi over 2x. Sweet. So to find the second derivative, which would be d squared y or dx squared, it's going to be the constant negative pi times outside function sine. What's the derivative of sine? Cosine. Keep the inside times the derivative of the inside is pi over 2. So to rewrite that, that's going to be negative pi squared over 2 cosine pi over 2 x. Okay, please practice on your own.